Hello students, today I am going to teach you how to prove the following formula for coefficient of correlation. Please see that before solving this example, first you should know the definition of what is correlation, coefficient, and what are the formula, what is the definition, types. In my previous video I have done all this, and now I'm going to simplify this example. Yes, if this video helped in the examination, please like and subscribe and share with your friends. Please watch the video till the end. We'll start now. Yes, here we start. So here they have given two simple question to simplify. So let us simplify this quickly. Coefficient of correlation they have asked. So they have told us to prove this two values and they have told us to deduct this answer. So we'll start immediately without wasting your time. So first I will take the value we have. So just take the pen and we'll simplify. Here we go. Okay, so first whenever they give such equations, students, first you have to take, so we have, I will take a part of this equation and I will simplify the remaining part. So I'll just take this as summation. I remember xi divided by sx minus yi divided by sy, the whole square. This is there already in the question. Let me prove taking this value. I will take only this value and I will prove the remaining part. That will be easy because summation, I can take the summation square as a minus b the whole square. Right, everybody remembers the a minus. Same way I will take this also. So what I will prove in this, I will take summation. I will just write it once again. So what I want to prove in this, so xi divided by sx minus yi divided by sy square is equal to, just I will bring this r inside, so this will become 1 minus r. 2n I will bring it this side, so summation xi divided by sx minus yi divided by sy the whole square is equal to 2n if I bring it on this side. So this is 2n 1 minus r. This is what I want to prove. I will take this as LHS and this I will take it as RHS. Similarly you can do for the second. I will show you now. Okay, so I have taken LHS. This is LHS and I will prove RHS. Now you know a minus b the whole square, so remember a minus b the whole square. So what is the a minus b the whole square? It is a square plus b square minus 2ab. Consider here a is equal to xi divided by sx and b is equal to yi divided by sy. So I'll just simplify this one. So LHS, I will take this as summation as it is. Now this is xi divided by sx the whole square. So square I will take in the denominator and numerator, then plus b square. So I will take here square yi square, yes, square y minus 2ab. So a is xi divided by sx and into yi divided by sy. What I have done is, just I have taken this and I have just squared this. Okay, finish. Then yes, summation, take it inside. What will get the summation? Yes, summation. So wherever the variables are there only we will get the summation. Like summation, x and y are the variables. So yes, x and xy are standard deviation. So I'll take summation x square divided by sx square as it is, no change, plus summation yi square divided by s square y. So if you don't understand, please students rewind the video once again, go through the video again and again, you will understand everything. This is 2 times summation xi divided by sx. Okay, I will take xi yi divided by sx sy. So what I have done, I have just taken a minus b the whole square and summation I have multiplied inside this bracket. Yes students, first you should remember the definition. In definition it is clearly mentioned that, in my previous video you can watch all the definitions. In that we must know that s square x is nothing but summation xi square divided by n, and yes y square is equal to summation yi square divided by n. Similarly, yes x and yes y is nothing but summation xi yi divided by n. We have already done this, and we have found out the mean of this also. So remember all these students, and very important, r is equal to summation xi yi divided by n, yes x, yes y. This is standard deviation, sx and xy. So we should know all these formulas. Is it clear? Okay, so then substitute all the values. Okay, one by one I will substitute, dear friends. Okay, let me simplify this. So this you can see in here, sxi square is there and divided by sx square is there. So if you simplify this one, I will show you on the right hand side on this minute. Okay, so here I have summation xi square divided by sx square. So we know what is xx square now, so therefore I'll simplify. Summation xi square is there divided by, this is summation xi square divided by n. Just have simplified the formula. So xi square and xi square will get cancelled. N is denominator of denominator, which is n. So this part is n, which is this part. This part is n. Therefore LHS is equal to, this part is n. So I'll take here n. Then plus. Similarly, we have summation yi square divided by n. Again we get, instead of x we have y. So again divide of divide, n you will get. So therefore I will take this as n. Now this is minus 2 times. Yes, here you can see summation xi square they have taken. So but here we get only n is there. So I'll just take this side. So this implies that n I will take it on this side. So this is nr is equal to summation xi yi divided by sx sy. This I will substitute here. You will get here nr. So all the values are simplified. Okay, now you can simplify this. What is common in this ones? So n and n will become 2n minus 2n r, and this is equal to, if I take out 2n, 1 minus r, which is your RHS. So this is how we have to prove this example. Very easy, very simple. Easily one can easily prove this. Yes friends, immediately wasting your time. Instead of wasting time, we'll do the next example quickly. Okay, now you can see if z is equal to x plus by, and r is the correlation coefficient between x and y, show that, yes friends, they have told us to show that this value r is equal to yes z square. So x, y, z, there are 3 variables here. So minus a square yes x square b square yes y square divided by 2ab 6 sy. So we have to prove this, friends. Okay, now you can see, we'll simplify since we know what we know, students. Yes, we know that we take z is equal to ax plus by equation. Therefore, we can easily write the mean of this equation. So that is z bar is equal to ax bar plus by bar is the mean of x, y and z. So in this, what I will take, let if you take xi, so number of all the variables, then it will become axi plus wherever xyz is there, just I am putting I, so this is going to become y. Okay, where I is equal to 1 2 till n, then in such case, then I will simplify this. Now I'll just take this equation number 1 and this I will take equation number 2. Subtracting equation 2 minus equation 1. So what I do? Zi minus z bar is equal to a. Now you can see a x bar is there and this is a xi is there, so a and a are common. So I'll take a xi first, then a x bar minus plus, again I will take b yi minus b y bar. You can see easily, students, what is common in this two. A is common, xi minus x bar, plus b is common in this two, yi minus y bar. Is it clear? Okay, now I will take the square and summation. I will square all these values, students, and I will take the sum of all. So I am going to first take the square on both sides. So zi minus z bar square is equal to, if you take this square, I am going to use the formula a plus b the whole square, which is a square plus b square plus 2ab, where I will take a is nothing but a xi minus x bar, and b I will take b yi minus y bar. So I will take just a square and b square formula. First I will square the first term, that is a square xi minus x bar, and then b square yi minus y bar plus 2ab xi minus x bar and yi minus y bar. Okay, so this two we get. Okay, now simplify. I will take the summation, multiply summation on both the sides. So I will take summation zi minus z bar square is equal to summation, a square is constant, so I will write a square outside, so xi minus x bar, plus here also b square is constant, I will take it outside, summation yi minus y bar plus 2ab, again I will take here summation xi minus x bar and yi minus y bar. Is it clear? So I have just taken the summation of all this. You can see summation of xi minus x bar the whole square, if you just remember the formula, students, it is divided by n, we take sz square, so we know that. Same way we take here, so you have to remember this, yes z square, we know that yes z square is equal to summation zi minus z bar the whole square divided by n. Similarly, it is sx square is equal to summation xi minus x bar. Okay, here square is there, please remember. Okay, square divided by n, and next sy square is equal to summation yi minus y bar the whole square divided by n, and the last one is sx sy is equal to summation xi minus x bar into yi minus y bar divided by n. So we must know this formula, friends. Then substitute in this equation. Therefore, here n, if I bring it on this side, it will become n s z square, which is equal to n a square s x square plus n b square s y square plus 2ab, as it is no change in ab. Here again n r, this time it is this, we are going to take this as r. So here we get n r, or if you take it on this side, so you may take the formula like this: summation xi minus x bar into yi minus y bar divided by n into sx sy. This formula I already studied, just have interchanged the role and you will get here sx and sy. If you further simplify this, you can see everywhere n is common, so I will take out n, divide by n, so you will get this as z square is equal to a square sx square plus b square sy square plus 2ab r sx sy. So easily you can collect the r value and simplify. You can just take this r value, students. So therefore what we get this as, remaining all these terms you bring it on this side, you will get 2ab sx sy, or I will keep this as it is, no change, is equal to z square minus a square sx square plus minus, this is also minus, we brought it on this side, minus b square s y square. So r is equal to sz square minus a square sx square minus b square sy square divided by 2ab sx sy. So this is what we wanted to prove. Again in this, if there are many other cases are there, if 1 2 is there, 2 3 is there, sometimes they substitute a is equal to 1, b is equal to 1, right? There are 2 more cases. Case 1, a is equal to 1, b is equal to 1, then we get different result. And case 2, a is equal to 1, b is equal to minus 1. So we get a case 2. So if this video is helpful for in your examination, students, please like and subscribe and watch the video till the end. And you can see that many examples I am going to solve in the same way. Please motivate me, help me to create more and more videos which is helpful for you in examination. In many exams, you can see in the competitive exams, you are going to use this formulas. Thank you so much, friends. Thank you watching till the end.